Hi guys, this is Sam. I'm just making this video to show you guys how to prove that a statement is a tautology or contingent or contradictory using truth tables. So first we're going to start with this disjunction. A or not A. So the way we set up the truth table here, we only have one variable, which is A. Only one statement, only one proposition, A. And A can either be true or false. And that's what we do on the left side. We put all the different propositions on the left side. And then we put the statement that we're analyzing on the right side. So you put A or not A. Now, A or not A is going to be true because it's a disjunction. It's going to be true if the first part is true, or if the second part is true, or if both are true. That's how disjunctions work. So A or not A will be true when A is true, because the first part is just A, that's true, or not A. So it becomes true. Likewise, the statement when A is false is also true, because not A is true. So we call this statement a tautology. A tautology is a statement that is always going to be true, and A or not A will always be true. Now let's look at the next one, A and not A. So we construct the left side the same way. A, and A is going to be true or false. And on the right side, you put A and not A. Now, A and not A is going to be false when A is true, because, well, the first part, A is true, the whole statement is saying A and not A are both true. And since A is false, not A is going to be false. So we say that the statement here is false. Likewise, when A is false, even though the second part is now true, the first part is now false. And so we say the whole statement, again, is going to be false. So we call this a contradiction. And a contradiction is a statement that's always true under all circumstances. And finally, we get to this next one, if A then B. Here we have two propositions that form the whole. We have A and we have B. So A can be true and B can be true, or A can be true and B can be false, or A can be false and B can be true, or both are false. That's how we construct the left side when we have two letters, right, in the argument. Here we have if A then B. We say if A then B is true when A and B are both true. Let's say the statement is if you have your dinner, then you can have your dessert. Well, that's true if you both have your dinner and have your dessert. Now let's say your parents say to you, you young kid, you can have, if you have your dinner, then you can have your dessert. And they don't give you your dessert afterwards, then they lied to you. So we say the first line is true and the second line is false, right? They lied to you in that case. You didn't get your dessert after you had your dinner. Let's say you don't have your dinner, but they gave you your dessert anyways. The statement was still true. Right? Maybe you emotionally wore them down and they gave you your dessert anyways after you skipped dinner. Let's say you don't have your dinner and you don't have your dessert, then the statement is still true. So here we see the statement under three conditions is true, and under one condition is false. This is the standard truth table for a conditional. So we say that this statement is a contingent statement. because its truth is contingent on the truth value of its parts. So this is how we use a truth table to determine the nature of a statement in terms of whether or not it's a tautology, a contradiction, or if it's contingent.